Let's finish up this chapter by examining two more kinds of methods and attributes. So we're going to look at class and static methods and attributes in this example. So here in my editor, I've opened the class_start.py file, and there's already some code filled out for the book class. So I'll just collapse this down. So we've already seen how the init function works, and we've already learned about instance functions. And we know, for example, that setTitle is an instance function that sets the book's title in this case. And the title attribute itself is an instance attribute because its value is associated with each instance of the object that gets created from this class. So now let's start with class level methods and attributes. These are different from their instance versions because they are shared at the class level across all instances of that class. Now that might sound a little confusing, so let's take a look at a concrete example. Suppose we wanted to make sure that each book object was assigned a specific book type when it was created, such as hardcover or paperback or ebook. Now we could define an instance attribute that enumerates these values, but since it's going to apply to all the book objects, it would make more sense to just define it once. What I can do is create an attribute at the class level outside of any of the instance methods, and I'm going to use all caps here to indicate that this is a class attribute, and I'll call it book types. I'm going to initialize it to a tuple that contains hardcover, paperback, and ebook. So then I can have the init method take the book type parameter, and then I can check to make sure that the given type is one of the values that the class allows. So I'll write if not, and then book type in, and then to refer to the class variable, I use the class name. So it's book.booktypes. Then I'm going to raise a value error, and I'm going to use my format string here to say that book type is not a valid book type. Otherwise, we'll just go ahead and set self.booktype equal to book type. Okay, let's also add a class method that returns the book types list. So to do this, I create a method and I use the class method decorator, and I'll define the method called getBookTypes. And this works on a class instance, not an object instance. So I'm going to return the class's book types constant. And then let's go ahead and print out the result of our class attribute. So I'm going to go ahead and call print, and I'll write book types. And once again, I use the class name to call the class method. All right. Oh, actually, I need to change my object code here where I create the books. So let's make the first one a hardcover. And then let's make the other one a comic. Okay, so let's go ahead and run. And here in my terminal, you'll see that we successfully print out the book types. So that's this line of code right here. But then I get an error, right? Because it says comic is not a valid book type. It's not one of the predefined book types that I've defined. So let's go ahead and change that. Let's make this paperback. All right. And then let's run again. And now we see that everything is fine. Okay, so let's go ahead and take a look at static methods now. So where instance methods work on specific objects and class methods work on the entire class, static methods are different in that they don't modify the state of either the class or a specific object instance. And I should point out here that there aren't really that many great use cases for static methods. They are useful, however, for scenarios where you don't need to access any properties of a particular object or the class itself, but where it makes sense for the method to belong to the class. In other words, it's a good way of namespacing certain kinds of methods. Whereas you might, in another way, create a global function. This is a way of taking a global function and just putting it in the class's namespace. So one good example of static methods is to implement a singleton design pattern. And remember, the singleton design pattern lets us make sure that only one instance of a particular variable or object is ever created. So let's imagine that we wanted our book class to be responsible for keeping track of a list of books. Now, we could create a global variable to hold all the books, but it might be a better approach to encapsulate that behavior within the book class. So what I'm going to do here is create a double underscore attribute named book list. And remember, the double underscore essentially makes this a private variable, and we saw this previously in the chapter. And then I'll define a static method that exposes this property to the consumers of the book class. So I'll initialize this to none, and then I'll create a static method to access it. So to create a static method, I need to use the static method decorator, and then I'll define my method. I'll call it getBookList. So then I can check to see if the book list attribute is null and create a new list. So if book list is none, then I'll just create a new one. And if it's already been created, then we'll just return the existing one. So now let's use this feature to add our books to a list. So I'm going to scroll down to the bottom here, and I'll write some code. So I'll create a books variable, and I'll assign it to the result of getBookList. Now remember, this is a static function. It's on the book class, but it doesn't actually modify the class's state. So then I'll write the books, and I'll append book 1, and then I'll append book 2, and then we'll print out the books. All right, so let's go ahead and run this. And here in the output, we can see that our books are being added to the list. And remember, we've ensured in our logic that only one of these will ever be created, right? So if it's none, then we create it. Otherwise, we just return the existing one. So we've namespaced what would otherwise be a global function to our book list. And this is one of the good uses of a static method. There are some other ones, but for the most part, they're really useful for namespacing what would otherwise be a global function into the namespace of a class.